In the earlier session on mass vesting, we tried to understand the concept of mass vesting, factors favoring mass vesting or mass movements, and classification of mass movements. We have analyzed the slow flowage of mass movements. In this session, we will try to understand other types of mass movements. Mass movements is the natural process, but today man-made or anthropogenic factors are emerging as major triggers to mass movement process. In India, there are few locations which are more prone to mass vesting process. Today, mass vesting in the form of landslides is assuming the dimension of a hazard. The main objectives of this lesson are to analyze the rapid flowage of mass movements, to identify anthropogenic factors in mass vesting, to know about the regions in India prone for mass vesting, to know about some preventive and mitigative measures. That is earth flowage. The rapid movement of water-laden soil material down the slope is known as earth flow. Movement of water saturated clayey or silty earth materials down low angle terraces or hillside is known as earth flow. It is common in humid climatic conditions. Earth flow is promoted by excessive water received mostly through rainfall, so that materials are oversaturated. Earth flow is more common on hill slopes and valley sides having clayey minerals. As the earth flows are viscous in nature, they move very slowly. Sometimes the earth flows in the hilly areas are associated with large slumps. It results from slope instability, perhaps due to human interference in the form of removal of vegetation and undercutting of the slopes. But it can occur on any steep slopes after a period of heavy rainfall, especially when the underlying rocks are impermeable. Earth flows are not confined to the stream channels. Thus, earth flowage occurs on the moderate to steep slope. The mass movement is either slow or rapid, and the earth material is saturated. Mud flow. Mud flow differs from the earth flow in that former may be noticed by the observer while the latter cannot be noticed, because earth flow is not very common. The conditions which promote mud flow includes steep slope, presence of unconsolidated materials in the upper surface, so that these, when mixed with water, becomes viscous fluid. Mud flow is a type of mass movement on an unstable slope similar to an earth flow, but of greater velocity because of the high percentage of water present in the mixture. Mud flow is a type of mass vesting associated with a flowage of debris containing large quantities of water which acts as lubricant. Mud flows are the characteristics of drier regions because in such areas the vegetation is sparse and the infrequent rains are often torrential. Mud flows are common in the semi-arid regions. At the time of sudden cloud burst, large quantities of soil and regolith are washed away in the form of mud flow. The end product of mud flow is a flowing tongue of well mixed fine mud, soil, rock debris, sand and water. The rate of mud flow is based on water content and the slope of the surface on which it is flowing or moving. It constitutes a considerable hazard in some parts of the world in the form of leher. Mud flows that are associated with volcanoes are called as lahars, which is a volcanic mud flow. Mud flows occur frequently on the slopes of the erupting or recently erupted volcanoes. Volcanic ash, dust and other fragments turn into mud flow due to heavy rains and flow down as tongues of the stream of mud, causing great destruction to human settlements. Debris avalanche. Debris avalanches are sudden downslope or gravitational movement of debris due to saturation by heavy rain. It is more characteristic of humid regions with or without vegetative cover, and it occurs in narrow tracts on steep slopes. Debris avalanches can be much faster than the mud flow. Debris avalanches are similar to snow avalanches, except that rock debris rather than snow makes up the bulk of their mass. It could be difficult in some cases to distinguish them from debris slide. The main distinguishing difference is that debris avalanches occur on very steep slope. The movement is the combination of fall, flow and slide. The material consists of mixture of rock, soil, etc. Landslides are relatively rapid and perceptible movements. The materials involved are relatively dry. The size and shape of the detached mass depends on the nature of the discontinuities in the rock, the degree of the weathering and steepness of the slope. Landslides are distinguished from the other mass movements discussed earlier. There is more rapid movement and moving mass has less water in it. 5 types of landslides are recognized as slump, debris slide, debris fall, rock slides and rock fall. Slump. Slump is the downward sloping of one or several units of rock debris, usually with a backward rotation with respect to the slope over which movement takes place. Slump usually takes place as intermittent movement of the earth or rock masses for a short distance and typically involves backward rotation of the mass, as a result of which surface of the slumped mass often exhibits a reverse slope. On a relatively gentle slopes, rocks can be dislodged and transported by the sliding mechanism. Sliding mass may be single block or several units. Block slumping involves backward rotation. Therefore, it is called as rotational slumping. Frequently, slumping takes place as several small independent units. The result is that the surface of the slumped mass has a number of steps or terraces. Undercutting of these slopes by streams, waves and man are most common causes for slumping. Slumping involves intermittent sliding of rock fragments, rock blocks or soils down the slope along a curved plane caused by the rotational movement of the displaced rocks that cover very short distance. Slump is the form of a slide most common in materials like clays, and sliding is facilitated by lubricated clays. Slumping of alluvial deposits of valley sides of North Indian rivers during monsoon period is common. Slumping is consuming a large chunk of land along the Ganga Valley in UP and Bihar. Debris slide. Debris slide differs from slumping in that the movement does not exhibit backward rotation. Instead, there is a sliding and rolling motion. Debris slide is more extensive and occurs at larger scale than the slump. Debris slide is promoted because of the saturation of the rocks due to water and sudden downslope movement of the unconsolidated mantle rock. The material involved in the debris slide is a mixture of soils and rock fragments. The debris collected at the foothill or the base of the valleys. Debris fall. Debris fall is the nearly free fall of the earth debris from the vertical or overhanging cliff or bluff. It is mainly found along undercut streams. Debris fall involves rapid rate of fall of weathered rock materials downslope from the great height, which are finer than the materials involved in the rock fall. The fallen materials collect at the foot or the hill or cliff base and form small mounds and ridges. Rock slides. Rock slides are masses of rock sliding down or falling of individual rock masses down along bedding planes, joints, fault surfaces. One of the largest rock slide occurred in Said Marai in Zagros Mountains located in southwestern Iran. Rock falls. Rock falls is the free falling of rock blocks over any steep slopes. In this process, small blocks of rocks become detached from the cliff face and fall freely to the cliff foot. They are more frequent in the mountainous areas during spring months when there is a repeated freezing and thawing. They may result in loss of lives and severe damage to property. Rockfall is an extremely rapid process and occurs without warning. Rockfall is typically the result of frost wedging. Frost wedging is a process where water enters the cracks in the rocks, freezes and expands and then breaks the rock apart. Frost wedging results piles of rock fragments at the base of the slope. The rock fragments are called as talus and the slope is referred as talus slope. Subsidence, in contrast to other types of mass movements, does not take place along a free surface, but it is the downward settling of the material with little horizontal motion. The most common cause is the slow removal of material beneath the subsiding mass. Solution collapse, especially in the karst region, is one of the typical examples of subsidence. Removals of material at depth by mining, the setting of faulted masses are other causes of subsidence. In the recent times, man has emerged as a significant factor of mass vesting and mass movement in almost all types of environmental conditions. Anthropogenic activities like deforestation for commercial wood, increase in agricultural land, construction of roads and dams and reservoirs, settlement activity on fragile hill slopes, diversion of river flow destabilize the hill slopes as well as valley side slopes and accelerate the process of mass vesting. Mass movements have registered increase in the frequency and magnitude of different mechanisms, mass movements. Deforestation, clearing hill slopes for cultivation like shifting cultivation etc. in the Himalayan region and Western Ghats have made the mountain ecosystem more vulnerable to increased frequency of different types of mass movements. The human-induced mass movement is also called as scarification. In case of mining activity and also for the construction of roads in the hilly or mountainous areas, man excavates and they disturb the rock strata and the slope. In the mining areas, land subsidence is common. Different regions in India are exposed to different type of mass vesting, though the nature and intensity differs. In the Himalayan region, debris avalanches and landslides are very frequent. One of the basic factors is the steep sloping areas which have greater potential for mass vesting. Frequent occurrence of mass vesting in the Himalayan region can also be attributed to the presence of sedimentary rocks and unconsolidated deposits. Besides, Himalayas are tectonically active. That is, earthquakes are common in Himalayas, which provides triggers to mass vesting. Other than Himalayas, mass vesting is common in Western Ghats and West Coast bordering the states of Kerala, Tamil Nadu, Karnataka, etc. The Western Ghats along the West Coast are relatively tectonically stable in the sense that this region is less prone to seismic activity, and geologically this region is made up of very hard rocks. Despite these conditions, this region is prone to mass vesting in the form of debris avalanches, rockfall and landslides. The frequency may not be as high as in case of Himalayas. The reason for the occurrence of mass vesting in the Western Ghat and the Nilgiris is due to the presence of slopes with steeper gradients with almost vertical cliffs. Besides, this region receives very heavy rainfall during the monsoon season. So, direct rockfall is quite frequent in these places along with landslides and debris avalanches. The impact of mass vesting in the steeply sloping areas and mountainous areas is becoming more serious in the recent times. Mass vesting, especially landslides, is responsible for the problem of land degradation, loss of flora and fauna, loss of habitat, change in courses of river or flooding, etc., assuming the status of a disaster. We cannot prevent mass vesting in the long term as it is a natural ongoing process. Preventing mass vesting is difficult because gravity will always exist. However, in many situations, there are certain actions we can take to minimize or reduce the impact of mass vesting. Slope support or slope stabilization is one of the most common types of mitigation for potential mass vesting. Slope stabilization can be simply done by plantation of vegetation. The roots of the plants tends to hold the soil in place. Planting trees can be simple and cheap way of stabilizing the slope. Proper engineering design during the construction of roads and buildings can control and minimize the risk of mass vesting. Controlling deforestation during engineering projects can minimize the potential of mass vesting. Mechanical or engineering solutions include construction of barriers like retaining walls. The steepness of the slope can be reduced by terracing and cutting the slope. Terracing the slope can control the speed of rapid flowage of mass vesting. Water can cause lubrication, slope, and therefore rock vest loses the friction. Cutting the slope is useful in improving the water from infiltration and friction. Mass vesting or movements can be in the form of slow movements or rapid movements. Slow movements are imperceptible, but rapid movements are more visible and noticed and occur without any warning. The rapid movements are in the form of various flows and falls. Mass vesting is a natural process, but today man-induced mass vesting processes is becoming one of the concerns from the environmental perspective. Mining activity, deforestation, settlement and construction activity along the steeply sloping areas and shifting cultivation are posing major threat by increasing the frequency and magnitude of mass vesting. In India, the problem of mass vesting is associated with the Himalayan region and Western Ghat. The need of the hour is to adopt some preventive and mitigation measures which can reduce the negative impact of mass wasting to some extent, such as plantation of trees along the slope, slope stabilization, construction of retention walls, early warning system, etc.